guys, it's good to see you all. I was thinking, since the Avengers broke up, and since times are so rough in the world these days, I thought maybe we should try to put a new group together. We could try to help students with their homework, and then we could fight evil in our spare time. I know, Thor, you could help with foreign languages because you speak Groot.
You speak Groot? Yes, the total on Asgard who was elected.
I am Groot.
But what do you guys think we should call this new group?
The Revenges.
Revenges?
Because I'm getting revenge. You're getting revenge. And you're two people. What do you want revenge?
I'm undecided.
I don't know about that name. I think that's a great idea. I agree with Groot. I think the group should be called the Math Vengers.
Cool. Cool. So cool.
I appreciate you guys bringing me into the group. So, for Thor especially, I heard about all your problems with your sister breaking your hammer, and she really did sound like the worst. So, I have a gift. I have a gift for you. What do you think of this weapon?
A king's weapon, meant to be the greatest in Asgard. In theory, it could even summon the Bifrost.
It have a name?
Math Breaker.
He needs the axe.
He needs the axe right now? Don't worry, I got you, Thor. Here you go, pal. He needs the hammer now? Here you go, Thor. Not the hammer, it's the axe. Algebra 1, we're at 12.6. Today we're multiplying with radicals. So I have a notes paper I'm working from that you have in your packet. So the first thing to just say with some words that I wrote on the paper is, if you ever have a root times another root, it's going to make an answer that's a root. If you ever try to have a root multiply a regular number, that just can't happen. You just can't do anything about that. If I just looked only at this part right here, here's a root multiplying a regular old number. That's all that can do. I can't change that. That's just stuck that way. But if I have a problem here where a root multiplies another root, we can make a new root by multiplying the radicands. Root 4 times root 9, I can just multiply these radicands and turn out a 36. There's two ways I could have actually tackled that problem, because root 36 is not the best answer. The best answer there is 6, because the square root of 36 is 6. If we wanted at the beginning to make the root 4 a 2 times a root 9, we could make a 3. 2 times 3 is still 6. But that's not usually the way that'll work. You don't usually have roots with perfect squares that just work to make things like 2 and 3. A problem like this, you can't do anything about those really. Root 6 times root 8 would be root 48. Roots times roots make new roots. Just multiply the radicands. And when I say radicand, I mean the number that's inside the root. Root 48 would get you a half point of an answer, because we always look to simplify roots, which is what we talked about yesterday. Yesterday I drew you a superstar list of numbers. 2, 3, 4, 5 was the beginning of that, like 4, 9, 16, 25, etc. These are called perfect squares, and these are superstars. And we want to turn them into just basic numbers. With 48, 16 is a helpful number that goes in 3 times. The root of 16 is normal 4, and the 3 is just trapped underneath. If that feels like a total mystery to you, go back and rewatch yesterday's video or look at that homework or do something with yesterday, because the skill of simplifying these roots is still in play today. Third fact on the top, over here toward the right, is anytime you have a root times itself, or if you see a root get squared, you're just going to get the radicand, because squaring and rooting are opposites. So if I ask you to do the root of 5 and then square that, the squaring and the rooting just eliminate each other, and this answer is just going to be normal, good old-fashioned 5. Root 7 times root 7, likewise, is just good old-fashioned 7. Because we could write this as root 7 squared, and squaring and rooting are opposites, and they eliminate each other to make just a normal 7. Here, if I do a root x times a root x, that would just be a normal old x. But this 4 isn't part of the root process. The 4 getting squared would need to be a 16, because 4 times 4 is 16. It's just roots times themselves that you eliminate the radical sign on. If I march ahead a column, here I have some regular numbers that can multiply to make a regular old 6. I have roots that can multiply to make a 12. And if you do that, you understand today. But if you stop there, you don't understand yesterday. Okay? Because we always want the radicand to be as small as possible. So we look to our superstar numbers. 4 is a superstar that goes into 12 3 times. So 3 is stuck underneath there. The root of 4 is 2. If 2 piles on and multiplies the 6, we'd like to have a 12 in the front. If we go to multiply these, 5 times 4 is 20. If we multiply root 8 and root 2, that's root 16. And if we multiply a root x and a root x, that is a good old-fashioned x. Anytime we have a root times another root that's a match, we just get that regular number, but without the radical sign anymore. If you do that, you understand today. But we need to think back to yesterday as well. 16 is a superstar number. 16 can turn into 4. And if 4 multiplies these other items, that can be an 80x for best answer. Fractions, you have a couple choices here. Okay, one choice for these would be to multiply straight across. 2 times 6 is 12. 3 times 2 is 6. Then we can simplify that. 12 over 6 is best as 2. That can't really go anywhere, so that's our answer. But canceling is also still in play. Multiplying fractions, you could cancel 2s. And you could cancel 3 into 6 going twice. It's a different way to get the same exact answer. If I go to do this problem, the 2 could multiply the 3 to make a 6 in regular number land. The root 4 times the root 4 could make a regular 4 following this kind of a pattern. Like root 7 times root 7 was normal 7. Root 4 times root 4 is normal 4. Grand total, 24. Alternative way to get the same answer, since root 4 is a superstar, and that's 2. And root 4 is a superstar, and that's 2. 2 times 2 times 3 times 2 is still 24. If I take a step to here, this might look to you like a distributing problem, and that's because it is. You can do distributing problems with roots around, and we are about to. So if we go to distribute, if we multiply these, roots can't really multiply regular numbers to change anything. We just want to write that as 5 root 2. Well, always, for whatever reason in math history, somebody decided we're going to put the regular number always in the front of the radical sign. Just the way they want that to be. I would suppose it's because if they wrote root 2 and then 5, and you were a little bit messy, it might look like root 25. That would be my theory on why they don't want the numbers to follow the roots. If we try to multiply these, the 3 has no friends over there, I mean other than an invisible 1, I guess, if you want to write that. So the 3 stands pat. Root 2 times root 6 is root 12, and that's pretty good. If you do that, you understand today, but you're still lacking on yesterday's, because 12 has a superstar that goes into 12. 4 goes into that 3 times. 5 root 2 can't be helped. The 3 is trapped underneath, but the root of 4 is 2. 2 could multiply 3 and get 6. And this is the best that we could do. If these were the same, we could have combined those. They would have been like radicals, but they're not. This is another distribute. Okay, so the 2 has no friends, so 2 is just going to be the way it is. If I multiply root 5 and root 5, that's a regular 5. In other words, a 10. And if I multiply the back half of these when I distribute, roots times roots make new roots, that would be a root 15. This might look to you like a foiling question, it's because it is. You can FOIL with radicals, and we are about to. So, for foiling, the F stood for multiplying the first, which are these, that's a 6. The O is the outsides, which are these. Positive times negative, that's a -4 from the regular numbers, with root 7 along for the ride. I is the insides. The 3's multiply to make a 9, with that root 7 along for the ride, minus, if we multiply these make a 6, the root 7's would make a normal 7, so normal 6 times normal 7 would be 42. And we have a little bit of like terms there. The 6 minus the 42 is a -36. The root 7's are like terms. A -4 with a +9 would offset slightly, but more to the positive side, +5, because we'd subtract those. Next one, same thing, it's a FOIL. 4 times 5 is 20, with root 2 along for the ride. 4 times 6 is 24. Root 2 times root 2 is normal 2, along with the normal 5. Normal 2 times normal 5 is 10. And then we'd have to multiply these, they're different types of items. So root 2 with a 6, I just have to write 6 root 2. And then look for like terms. 24 and 10 makes a 34. And then the 20 root 2 and the 6 root 2 don't change the root 2, but 20 plus 6 is 26. Last one of those, again, another FOIL. The firsts make a root 12, plus the outside is a root 14, plus the inside is a root 18, plus the last is a root 21. If you do that, you understand today completely. If you leave it there, you're lacking some older knowledge. I think I said yesterday, 2 days ago, I believe, that we simplified roots. But we check our superstar list. We look and think, can 4 or 9 or 16 or 25, or the list would go on if I wanted it to, can any of those numbers go in? And on this, the answer is yeah, 4 helps us go into 12 3 times. None of those numbers go into 14. 9 goes into 18 twice. None of that really goes into 21. So the 4 can root and be a 2 with the 3 stuck underneath. 14 is stuck. 9 can be a 3 when we root it with a 2 that's stuck. 21 is stuck. That would be our best answer. And these last several answers, it doesn't matter what order they're in. They're just there. So if you had anything out of order, no harm done. Homework we're working from this is 514. 514's gonna go from 1 to 28, skip a few, and then go to 38. 38's not really any harder than the earlier ones, so I'm not sure why that one's isolated down there. I don't particularly see anything that's unlike what we have on the board, so you should be in pretty good shape. If you understood the board, you're good. If you don't understand the board, email me, we'll talk on Zoom or do something. See ya.
Call. It's not that easy.
Hello, Ted? Hey, no, this isn't Cap's phone anymore. This is the Math Wizard. What's up? Yeah, Cap isn't here. But I have been thinking about that problem you were having with your time travel machine. I think if you would try a Mobius strip, I think that might be the key to the whole operation that could bail you out. Yeah, I think that would work. All right, yeah, hey, no problem. Glad to help you out anytime, bud. See ya.
Sorry, Mr. Stark, but I'm the real Iron Man.